Fresh.
It says
Refreshing.
It says waiting.
Waiting for debate hub. Uh-oh. Come on. Nope.
Technical.
Okay, something's happening.
Oh, there we go.
Okay, here we go.
It is?
Yep, it worked.
It worked.
Yay.
Yay.
Oh,
We did it.
Is this live?
Welcome.
Is it live?
And
we're live now.
And as we start, the battery of my fucking mouse has decided to give up on me.
Oh, now it's your battery problem instead of my battery problem.
Yeah,
Hi, everybody. Welcome back to Debate Hub. I am Chesh, your master debater. I'm here with Maanyaa and Landon to talk about volcanoes.
And is here, to be more precise at the moment.
Don't meet me. Get out of here. Landon, what's going on?
We were just watching Chesh do the vertical challenge and change a safety device, which Maanyaa, I'm sure, will encourage her to put the batteries back in because they're important.
Don't tell Maanyaa that I didn't put the battery back in, nor did I plug it back into the thing on the ceiling, and nor did I even put it back on the ceiling.
What?
I took it apart and I left it on my counter.
It's a safety thing.
I'm not sorry.
You can see my pores.
How are you doing? Hello. How are things?
How's the volcano?
Good.
Yes.
It was a short weekend. Everything was crammed into 4 days at work, and everybody was like, ah.
And how are folks in the chat?
Hi, everybody.
Chesh is like, by the way, hi.
Hello. Whoa. What are we looking at?
Hello.
Oh, the landing.
What's that? Ooh, nice.
So I would like to congratulate the international team on completing a successful Artemis 2 mission with all kinds of milestones and attention to science and cooperation. And if people cooperate and are nice to each other, they can do really good things because it's nice to be nice.
Yeah, don't be like Trump. Be like NASA.
So yeah, no, seriously, it was an amazing thing to watch. The details, the data that's coming back is just extraordinary. And I also like the fact that they sent out 4 astronauts who are highly articulate, who are very professional, and very
all
and
I
also
saw
very
was
human.
the counter of the Canadian being like bombastic side-eye.
Bombastic side-eye. Oh yeah, I heard there was some there was some bombastic side-eye going on when they were trying to talk to Trump, and it kind of felt like that they ignored Trump and he had a tantrum about that.
to be fair, to understand, there is a delay thing, and kind of the protocol
How
that
long
they
is
use
the delay,
in talking.
Landon?
The 2.5 seconds.
How long is
on there? And
it's 1 point something.
And so the procedure is that they speak and then NASA speaks, and so it's back and forth, right? And so they'd said something and were waiting for the other side to say something, and understand if you watch the mission, there'll be exchange about something, and then you're done. You don't sit there and say, okay, I'll see you later, have a good day. No, you just continue working.
Yeah. Yeah, because that's one of the basic fundamentals of communication. You just need to get the message across, the main message that matters across. That's it. And if the message has made across, that's all that's needed. That's it.
Well said, Maanyaa. It's like you understand such things.
That's the first fundamental principle of telecommunications. Everyone, you're welcome.
Yeah.
Quality does not matter. The comprehension of the message matters. That's it.
The way to go on that, and I'm looking forward to Artemis 3, where they will practice space docking and other sorts of things. And do for. So we talk about volcanoes, because this is actually, after all, Volcano Watch, 26th April. Well, thank you for joining us, and I hope, by the way, that you can click the like button because that helps us with the algorithm. And if you aren't already a subscriber, right, that subscribe thing, it's kind of what it really means is that you say to YouTube, we like this channel. And so you can like the video and you can also like the channel. Liking the channel is good, and it's free. Chesh won't go and annoy you with messages. There's no way of doing that. It's just I like the channel, so I hope you like this channel. And so yes, and hello to the chat, and even hello to those people in the alleged continent, which I would fun seeing when they were coming entry in. You can see the coast of Australia, allegedly upside down, allegedly. So we've talked about volcanoes here, and we live on a planet that's wiggly wobbly with lots of volcanoes. Now, as of the end of March, we had 41 volcanoes that were continuously erupting. This last year we had 63, and we're not even quarter way through or third way through, and we're at 47. So we're on track for a reasonable number of volcanic eruptions. And if you look at where are they, well, here is the map of where they are. And in Europe, Stromboli is erupting. Strangely enough, Etna's not erupting. It usually is. Etna's kind of has paused a little bit. Iceland has a volcano because I think volcanoes are famous for having lots of letters, and so this T, lots of letters, A, volcano is unrest to see whether or not it actually erupts. And in Africa, we have Ethiopia has its volcano area where the cotton is being ripped into two. There's a barren island has joined the set off the coast, and a couple in DR Congo and one in La Reunion. Indonesia leads the pack with 7. It's usually somewhere between 7 and 8. Indonesia is still quite volcanic. If we look in the Americas, Alaska, Canada, Great Sitka continues to be unrest. It's not erupting. It's in sort of a watch situation. Of course, in Central America, the Central Mexico volcanoes, it kind of continues eruption. We got Peru, Guatemala, one in Nicaragua. Down in South America, we have a Colombia volcano, 2 Ecuadors of Peru, and there's a pair, 2 that are on the Chilean-Argentinian border from the Andes. In other regions, we have the Sandwich Island volcano that's erupting, and of course Mount Erebus, which is almost continuous in eruption. That's down in Antarctica. They say Kilauea is erupting. Papua New Guinea has a pair. The Santa Cruz Solomon Islands has 1. Vanuatu, Tonga, and are there. The Kamchatka Peninsula, Russia has 5. Whoops, sorry for that. And Japan has 2, and the Philippines has 2. So the ones that are actively spewing stuff out, it's a time of this thing. So we're doing pretty well. Now, with regards to, we generally follow the Kilauea volcano in Hawaii, the Big Island, and we just had episode 44. We missed it by a day.
Dang.
It began last night and had about after about 8.5 hours of continuous fountaining on the north vent, sending tephra up into the public areas of the volcano. We had a overnight. Of course, we had the glow of the eruptive vents. Seismic tremors are kind of in their pause thing. Their sulfur dioxide during episode 44, the sulfur dioxide emission rate was 208,000 tons per day, metric tons per day. That's typical of an ongoing eruption. So 208,000, that's a lot of gas.
That's a lot of tons.
Yes.
That's a ton of tons.
Yeah, it is, and usually when it's paused like this, I guess between episodes, it's usually between 1 and 5,000 tons per day. So yeah, we have a pretty good thing, a recap of the episode 44 that occurred, 8.5 hours, and it's interesting. This time it erupted from the north vent, whereas the south vent sort of dribbled, but the north vent was the one that did. So it's a single fountain this time. And the actual height of that eruption, that vent, was lower than previous. I believe the set, if I recall, was that it was only about 150 meters tall, which is tall, but it's not. It hasn't been. It been.
Yeah, it's almost less than half, isn't it? Almost half.
Yeah.
Than what we usually see.
And it's interesting that I only had one vent, and it was even less than that. If we look at the tilt meter, which is one of Chesh's things,
I like the tilt meters because I kind of understand them.
Yes, and well, she understands lots of things, but in particular, she likes this one, and it's because it's nice and spicy. And here is we're looking at the day thing. Here is the basically the fountain occurred as it dropped down. And it dropped down 5, 10, 15, almost 18 microradians. So it's a pretty good tilt drop.
Fun fact about me, anytime I make any decision in my life, I check the tilt meters, and I use that to make my decisions.
Yes, and of course, if you look over the week, you see the thing in repose here, and for the month, this shows you what happened. Right? So we're a month since the sun, because this is now Pele's time of the month, and what we see is that we had just one eruptive event during this last month, and it was yesterday. And you can see how the climb up to it was kind of wiggly wobbly for a while, and it'll have a little deflation inflation event before doing the plunge. Again, this fits the model that there was a gas cushion at the top of the magma chamber, is a kilometer below the surface, and that gas chamber reached pressure point where it was able to break through and shoot a fountain. From the 3-month period, we can now look at that stuff, and you say that you know it was a between 43 right here. This is at 43. And 44 over here, 43, 44, longer period of time, and it was a little. It didn't get quite as high, and a little, very, very different sort of form of a slope.
So, if I'm not wrong, the inflation was lower, was it? And then the recovery was also lower afterwards. Is it?
Mm-hmm.
Or was it?
Yeah,
was the inflation lower?
It erupted at a lower tilt than before. Later on, I'll show you.
At lower.
Yeah,
and then
I have later a graph showing you the whole thing for the last since this eruptive period. There, but yes, it broke through lower, and the drop was lower. So instead of doing these deflation inflation like events to reach a peak, it stopped early, which was kind of interesting. From the point of GPS as well, we do see the caldera expanding, contracting. In their case, from the end of 43 to the beginning of 44, the diameter across the caldera moved up about 15 centimeters. That's about 6 inches in that other system. For there, you can see how this is where the apostolic thing started here on this scale, and you can see it's basically this up down thing. So from a point of view of the expansion of the caldera, it's kind of in keeping with the rest of it. But from the point of view of the tilt, it's not. Here is a graph showing you the entire episode from Christmas Eve 2024, and these are all the episodic eruptions. And you can tell this last one here is very different than these things in the past.
Yeah.
As Maanyaa said, it broke through at a lower tilt.
It had,
and it took longer.
Yeah.
Go ahead.
Yeah. And it recovered also really like low, isn't it? The recovery.
Yeah.
If I'm not wrong, the recovery is also lower than last time.
Yes. Yes. So I was talking about there. I mean, so it is interesting that frequency is getting longer, and and it broke through at a lower tilt, and then went down less. The drop during the set was also less. From the point of view of the fountain, the height of the fountain was only 200, they saw it was only about 240 meters as opposed to 540 meters. Right, 540 meters at 43 was a record for kilowatt.
Can we zoom in, Landon, please?
Yes, thank
Josh
you.
was about to ask that, I think.
Okay, so
see, I don't even need to be here.
We need chess. Chess is important. So here's 44. Here's 43. So this is the one for yesterday. This is the one for today. She had a rough time. She was having to listen to various interesting Canadians and comment on them. So give her a little break.
And also me judging her for her smoke alarm. Yeah, she's mad.
Yes. I'm doing it because Maanyaa is a professional at that. So. So we had, it took 30 days between 43 and 44, as opposed to 22 days or 12 days and so forth. The fountain was less. Also, the volume was down, right? This is the approximate volume in million cubic meters, and the volume was only about half of what we've been seeing there, although 40 was one of those short things as well. But also 40 had a period of 12 days. So this was 40 was a quick restart again. And so people said, well, it happened faster, so it didn't have enough so much pressure. The height was also at 250 meters. So the height was lower and the volume was lower. Same thing, height was about the same, the volume was about the same as what happened in episode, in these prior episodes of like episode 40. So, and again, the thing that also is different is we only had only the north vent fountain. The south vent sort of had precursory flows. When we watched it before, when it sort of gets near erupting and it kind of dribbles out a bit and stops and drops. Both were doing that. But when it came to the actual event, only the north fountain occurred, which was interesting. This was the map of the ashfall tephra that occurred in episode 43. That was a month ago. And we see here's the scale in terms of kilometers up here. And this talks about the amount of material. So it actually reached Hilo quite a bit. Basically, you had Pele's hair with things that are about 2 millimeters or less ash, right? You had the thicker one as you got closer to the event. You got larger material, and in this darker area is where you had almost continuous cover of the tephra. This occurred because the trade winds were blowing instead of to the southwest, were blowing to the northeast. That caused this to occur. From the point of view of the map, this is showing you the caldera summit that's being filled in this down drop walk, where the vents over here, this is where the two vents are. And in this case, only the north one erupted. The south one just just dribbled. And again, it's on the south east corner of the island. From the point of view of what's happening, I wanted you to draw your attention to this section here, showing you sort of the profile. So this line B was the collapse of 2018, when the summit collapsed almost 500 meters down over a period of time, and it's been slowly filling it in. At present, this orange line here is the current level. It's filled up, out of the 500 meter collapse, it's filled up 463 meters on average. This area here is higher because this is where the fountains occur, so you get more material. This gray line is what it was before it collapsed. So, and this area is getting close to the rim. This area still has a little bit to go. But it is definitely moving forward. Earthquake-wise, this last week we had, of course, we see the typical earthquake clusters. This is the summit here where the vent is, and we see lots of shallow quakes. Also to the south, this area here, this pretty orange area, is believed where the upper magma chamber is about a kilometer before the surface sits. And if there's earthquake, it's because we think there's a foam top that pushes against the holes and cause an eruption. This spot over here is deeper. These blue things are deeper. They're about 30 kilometers deep. This is believed to be where the uplift from the mantle is coming up, right? This is the hot spot uplift. And
so
one of the, go ahead.
It's shifting around the south side of the crater and not just erupting.
I mean, you're talking about this area here. You're talking about this. You're referring to this area here.
Yeah, the south side of the crater, right?
Yes, the south of the crater. So the crater is here, and these are kind of piled in the south area.
There's lateral
south of it, which also where that magma chamber is believed to be is a little bit south of it.
So there's lateral movement also along with the vertical movement, right? So that's what's
So this, and you're saying this stuff here is the weight of the island pushing against the ocean, right? This is basically it's creaking along these lines. This is the material coming up from the mantle, deeper in. And again, it appears that the rate of this average over time is about 3.5 cubic meters a second, whereas the rate coming from this chamber is about 6 to 6.5 cubic meters a second, telling you that there's more sitting out this chamber faster than it's coming in.
So why did we have like a burst of like earthquakes on the south of the crater when we had the vent, was it in the north that was, going off? So why did that happen? I
mean, if you look at what's happening here, if we go right to this thing, the cluster of quakes and the magma chamber is believed to be sort of around here, right? About a kilometer. This is the area under which, about a kilometer deep, where we think the upper magma chamber is.
Yep.
And one of its vent holes, it basically has a pipe from here to these two holes.
Okay.
We've seen it erupt all along this area, but this seems to be the favorite spot. So this is the area, and the deeper magma chamber is around 6 to 7 kilometers deep, and that's the one that's responsible for these deeper quakes, right? There, you see that these orange dots here are around the 6 kilometer deep layer. That's the deeper magma chamber. The yellow, the red dots up here are up higher. So we think that we've got two magma chambers in play, and the upper one is closer to where the vents are. The lower one is down here. Yeah. The thing that seems so significant is that there's more material going out than in. We'll say at some point means that they think this eruptive episodic thing will pause at some point because it's going to run out of stuff, we think. If we look at the month, that was the last week. This is the month, and we can see there's a whole pile of things where the side of the island is sagging into the ocean. There certainly is still plenty of material coming up from the deeper end, because this is a 30-kilometer deep part. And we see that there is still the two magma chambers, the lower one and the upper one, still active here. If you look at what's happening with regards to, go ahead.
I have a question. So there are deeper quakes, and then there are shallower quakes, or they are longer quakes, or shorter quakes, or small quakes, or are they the same thing?
So this is showing. So the redder is the more shallow. The red ones are relatively shallow, and the orange ones are a little bit deeper. So we think from this area that most of it is in that 6 to 7 kilometer deep thing because again, the model is that there's two magma chambers for Kilauea, 6 to 7 kilometer deep one, where the carbon dioxide boils, and the one that's around 1 kilometer deep is where the sulfur dioxide boils. The pressure drops and it's able to boil. And so we see most of the quakes occurring in this lower one. In part, it seems that magma chamber seems to be contracting because there's more going out than coming in. So at the point, its pressure should...
it's is it redistributing the pressure or what?
Yes. And that's one of the reasons why we get these pulses, because it takes time for the carbon dioxide to boil in the lower magma chamber and push its way up to the upper magma chamber, which has kind of a foam top. And that foam top has to compress before it goes whoosh.
So that's what it was, right? The lower chamber was kind of a supply, and the upper chamber was a reservoir. Is that what we had to as a conclusion last time?
Correct.
Yeah.
And the lower magma chamber is supplied by an even deeper pipe. And so these blue things over here, so here's the summit. These blue things here are the 30-kilometer deep pulses that occur. If we look at over time, we see that the that this 30-kilometer deep things is kind of continuous. There still is this material coming up from the hotspot and deep in the earth that reaches this area here, and there's pipes that head to the Kilauea, pipes that go to Lohi, pipes that go to Maanyaa, pipes that go to Volcanoes. So they have the active volcanoes in this area. In the case of Kilauea, it sees its feed from the upwelling here, deep upwelling, and it has two spots: the 6 to 7 kilometer deep thing and the shallow thing. Shallow thing only really gets activated when there's enough carbon dioxide boiling in the deeper magma chamber, 6 to 7 kilometers deep, to push material to the upper magma chamber where sulfide boils, and then the top foam top gets enough pressure that it pops through and gives you a thing. That's what we think might be happening. Of course, what Pele actually is doing is her business.
It's entirely her business.
Yes. And so again, I wanted to talk about, again, we see in terms of quakes, we look at quakes here, we can see that in the past 7 days, there are certainly 84 quakes in this area, and lots of stuff. But if we home in on the summit here, we can see that there is a pile of quakes that are showing you again, in terms of we see the deep and shallow ones is what we're showing here. So these are relatively deep versus these are this is the shallows. The orange ones are shallow, and the yellow ones are deep. This is the last week. If we did 30 days, we see a similar sort of thing showing you what happens where again, there's a pilot here. But when we look at what's happening on the surface, right? This was this morning when I visited the thing, and it's Hawaii, so there's lots of clouds there. It was raining. Let's see what happens now when we go and reload it.
Hello? Hello?
We ain't found shit.
Yeah, I think there's you could tell here's the rim up here, and you can tell this is where the vent stuff is, and there's gas stuff up here. This was earlier today, and this is what it is now. You can tell there's kind of a glow where the vents are in this area here. If we were a little bit later, this one shows you V3, so that was V1, V2, V3. That was earlier today, and if we go to right now, okay, here. Now you can see that you could tell here's the rim. The vents are here, so you can tell there's a lot of steam stuff coming from the vent, but it's also cloudy. This was the camera looking back across the caldera, and there we go. That's a look at a better thing. So what you're seeing here's the caldera, right? You can see the heat from the last flow because the vents are here. This is the down drop block in here. We can see this is the material that is hot from the last eruption. It was yesterday. And you can see the winds blowing the steam. So part of the problem was that the cameras we're seeing are in the middle of this steam stuff. The winds are in odd direction. But that's what it is. Okay. From a point of view of the actual gas conditions are relatively good. There was a lot of issue here on the steam at the steam vents that are unhealthy for sensitive groups, but it wasn't too bad. There. So let's go and look at what's been happening there. So USGS continues to sample after eruptions. They go down onto the floor with a helicopter and collect and put back the old ones. So we see that again, they wait until, of course, the winds are blowing favorably and also not erupting to collect samples. And here's a helicopter flyover. Here's the south vent that's sort of spattering. You can see a little bit of lava deep down inside.
Wow, that's beautiful.
From that area. Thank you. This shows you the side vent here. So this is the side. Here are the two vents, right? Here are the two vents. You can see how much it's built up. How much?
Is that yellow stuff sulfur?
Yes.
I thought so.
You'll get sulfur deposits down in that area. Various gases. It usually comes from the fact that the outgassing, right? If you remember again, the gas that boils in the upper magma chamber is sulfur dioxide. So let's get some sulfur. Yeah. So now, once it starts raining, stuff washes off, and you get nice sulfuric acid. But just don't lick this rock.
Oh, I see what happened there. So we had sulfur dioxide, we had the rain, and it all combined together. So that's probably acidic, whatever that deposit is over there.
Yes. It is why Maanyaa will recommend don't go down there and lick those rocks. It's probably not good for you.
Do not lick those rocks. No. Why does Landon come with the most bizarre thing for me to say no to? Do not.
Hey. And so you see, we see that this is the north vent. In terms of this is the north vent here, and this is the south vent here, and we can tell. I zoomed in too much. And again, you can see that the rim is up pretty close. This area here is building up pretty good. This is the view from the volcano house. So if you go out the back of the volcano house, they have this nice interpretive walk along the rim with national park signs. You're in the national park, and this is the view looking over. Here are the two gas vents over here. So when they fountain, you get a nice view in that spot. If you look over further, here's another thing. This gives you an example of the massive ash pileup. So here are the two vents here, and you can tell that the ash pile is actually built up above the rim. Pretty thick material on the side, because when they erupt, they flow going to the left. And again, the tephra is fairly deep. If you're looking back beyond the vents, these were ridges from older cracks from older eruptions that are now being covered a lot by ash, volcanic ash. And it rains, and so you get erosion. So you start seeing, because it's not going to sit there. This pumice is going to basically wash as rains. And Hawaii experienced some really significant storms with a lot of rain, and so this is part of the erosion that will be ongoing. Tephra itself is there, so they had a lot of ash here in what's called the military camp. And for those that know, this is a historic camp. There's a thing called Kilauea Military Camp. It's not an actual camp. It was opened in 1916. Group of Hilo business people raised funds for operating a camp on the Bishop, and it served also as a prisoner of war camp for Japanese soldiers, and but it became one of the 3 Armed Forces Recreation Centers property. So again, it's not a military camp, it's not a military base, but it's also available for stuff. And in fact, any armed forces person from nearly every country, there's probably ones that they wouldn't want, can go there, and civilians go there. It's a nice little, again, it's a historic camp there on the park.
Oh wow!
So here is the picture from the episode 42. Excuse me, 44. So if we look at this set here, we can see the flow of material coming. That flow of material coming from the vent. We see that's only really one of the 2 is fountaining, and the way the winds are blowing, it was blowing the ash sort of in an unusual direction. Most of the ash goes the opposite direction, so that's why you get this giant pile of ash showing up on this side. Again, it was only one of the 2, the north vent. The south vent over here was relatively quiet during this eruption.
Oh wow! Okay, yeah, that looks nice.
And again, it's 250 meters lofting rock. 250 meters up is a pretty big feat. We kind of got spoiled to the meter plus stuff. So it's a significant fountain event. It's just not as the other thing. If you look at the base here, there is again a lot of material coming out. The vents were lower. So instead of around 500 to 600 cubic per second, it was on the 250 meters per second, about half. One presuming is that maybe there was only 2 vents that were going, and so they had half the stuff coming out. Maybe there. But this bird here is well in front. This bird is not in danger of getting clubbed by lava. Most birds don't do that. If you look from farther back on one of the side vents, again, you can see that the fountain from farther back on the ridge, on the rift zone, showed that the fountain was getting up near the rim in terms of height. This one was a little bit later on, but you can also see the atmospheric effect. The gases and hot heat there creates a clouding and condensation vent, and also ash that gets carried aloft. Here's another one showing you the fountains and the long trails there. We saw in the photo of the caldera, the webcam photo, we saw the steam coming off this area because this is where the hot material is for this eruptive thing. again, ash is a these things, because it's, even though it's only going about half the height, you do get this sort of ash falling. There again, these are sort of fluffy. It's sort of like it comes on sort of like snow, but it's warm. It's not cold. So you're not getting pelted with rocks. You're getting fluff that comes down on you. Again, you'll see here that the grounds and lawns get sort of covered with this ash dust. Even in Hilo, this is from the town of Hilo. Looking back, you can see the clouds coming from the eruption, and the winds were going in the direction of Hilo, which is where why you're seeing the condensation and ash coming down. Similarly, you can see this is one of the roads in the park, and you can see how they've got to go in and kind of try to clear this off. It is abrasive, so the better way to do it is to wash it off rather than try to scrape it off.
Yeah.
What was that? Here, and you can see again, near the cameras, they have larger chunks coming down.
That song was the sound of the consequences of my actions of taking out the batteries for my fire alert and then not plugging it back in.
Yeah.
Oh no!
And little bits of ash that sits on the ground. Again, tephra, you can see on the roads get kind of coated with it, and you can see the tire tracks that kind of dig it around in that area. But this is part of the on the rim.
A warning.
The rim things showing you stuff.
Yeah.
So
again,
I wanted
a warning.
to.
Don't play with this ash. Please do not play with this ash. All right. Even if like a micromillimeter of it gets in your lungs, you're done for. So do not play with this ash. Just stay away from it.
Yes. Use again. Mask is a really good thing when you get this ash falling down there. So I have given Chesh about a 2-minute thing showing you the 44 fountain and the
this is beautiful
sound.
Look, I was ready and everything.
Oh, this is beautiful. Oh my god.
Just enjoy this.
You can see the steam also going up, or the gas coming
Yes.
up. Oh, wow. That's not the wind, that's the lava, right?
Yes.
Oh wow.
The gas is coming off of the heat coming off of the lava.
Yeah.
Intense.
Oh, wow. Don't want to joke, but I guess this is what Pompeii was hearing when the lava came through.
Yeah, and you only get the red when it's actually moving, because it forms a crust quickly.
Yeah.
When it meets the cold air.
Yeah.
So you only get the red
So
stuff. Because night it'd be glowing really. Go ahead.
Do not stick your pinky finger or your index finger in it, or any part of your body. All right, don't do that. It's very tempting, but do not.
You see the front slowly advancing. The fountains are way up this, where you're seeing the edge of the front slowly advancing across the crater floor. And it found it there. There's another side view.
Ash's mom said something very interesting in the live chat. Need a giant marshmallow. How far do you think this marshmallow will be for it to cook easily?
Joke's on you, that is a giant marshmallow.
Ah, there you go.
Everyone, please roast Chesh. It's in the live chat. I didn't say it. It's a Shano in the live chat that said it. It's like
the fountain kind of comes and goes. It has
spreading the happiness.
It has surges of material, and then up down. So even when it's fountaining, it has this pulsing type of a thing occurring. And you see the atmospheric condensation from the gas coming up. So that's a little bit of showing a little bit of the what the eruption would be like if you were there.
Oh wow, the reverse. That's the reverse. Nice. Oh, that's mind warping. That's so mind warping.
Wow.
My brain is like, stop. Okay. Stop. My brain.
Yeah.
Okay, please have some mercy.
Okay, fine. I'll stop.
So,
thank you. Appreciate it.
Yeah.
So, tell us about the Maanyaa, if you please. Tell us about the predictions. While in the chat, we're going to ask you, please consider your predictions for next month.
So Landon, if you want to come back. Also, there are a couple of questions in the chat as well.
Yeah. Okay. Questions would be better to go with first.
Okay.
Okay, if you want to go with questions first, we got a question from Dead Red Eye that says, "What is the deepest depth we can detect seismic activity?"
It is usually deeper seismic activity can occur on continents because the crust is thicker, and 60, 70 kilometers is probably the things I recall. Now, there may be records that I'm not aware of, but that seems to be really, really deep stuff at 60, 70. In the case of where it is out in the middle of the ocean, the ocean plate is much thinner. So 30 kilometers to 40 kilometers is kind of the bottom of the crust depth at the ocean, because the ocean is a lot thinner. Whereas continents, it gets thicker. And of course, there's probably spots, continents where it's much deeper as well. So.
Follow-up question from Orange Dot that asked, how are tremors that far beneath the surface detected?
By the vibrations, right? The earthquakes are sound, and the pulses go through the earth. You have multiple sensors that detect the vibrations, and you can rule out a local thing like somebody stomping around near one of the things because it's more intense right at that sensor, but the other sensors that may be farther away don't pick it. The time that the pulse arrives allows you to triangulate. So if you had an earthquake in between three seismographs that are kind of like on a triangle, and they arrive at the same time because it comes from the center, because the center of the triangle is where it comes. If it was off to the side, it would reach one first or the other. So they can triangulate both in depth and direction as to where the quake was from, and by multiple seismic detections, again the sound, the wiggles, they can pinpoint where it started.
So if you also
God
remember,
Mom was asking which volcano were we watching, and it's Kilauea in Hawaii.
The Kilauea volcano on the Big Island of Hawaii in the middle of the Pacific Ocean. It's one of the most active volcanoes on Earth, but it certainly has others that are also equally as active.
Go ahead, Maanyaa.
So
and we're seeing pictures from the Volcanoes National Park, which is a great place to visit.
Links in the description.
Yeah, if I may add, that sound travels faster in solids, slower in liquids, and then slowest in the air. So that's how, and if we know the type of material that the Earth's crust is made of, we can we can figure out at what speed the sound will travel. And that gives us the depth, depending on how long did it take for the sound to reach the surface. So we and what's the speed of the sound in that material. That helps us pinpoint the location of where it came from.
And I think Orange Dot said it very well. Local sensor intensity, triangle math. That's how that sort of thing happens. So those are the quakes that are the intense thing due to rock breaking because the magma is cracking the rock. There are other types of quakes, very long period quakes. So you might think of the snap and the pop of something as being very sharp, but there are quakes that take a long time, last hours, where it's very slow. And in fact, you could argue that those tilt meters we saw of the mountain expanding, contracting over a month is an example of very, very, very slow motion of quakes. But yeah, earthquakes are just sound, and they go through rock pretty well. Now,
what are our predictions?
Most of those quakes, by the way, that you saw on that graph, it would be hard, it'd be very difficult for you to detect. If you were sitting on a chair and you're really quiet and you're really paying attention, you might feel a wiggle, right? I mean, it's not like buildings are falling down. So these are most of those were fairly small quakes. Occasionally it has larger quakes, but usually because there's so much shaking going on, it's hard for it to build up a big earthquake, especially when it's erupting like that. Yeah.
I remember when I was in Christchurch, when I'd recently moved to Christchurch in New Zealand from Auckland, and one night I felt like as if a car had driven right into one side, into a wall on one side of my house, and there was a big bang, and the whole house just shook. Like there was vibrations going on through the house, and I was like, "Did something hit my side of the house?" I got out, I checked it, and there was nothing there. And then next day, I discussed it with my colleagues, and I was like, "Yeah, you were right above the epicenter of the whole thing, so that's why it happened like that."
And for the bigger quake, if you feel stuff, there are pressure waves, P waves that go through. They're actually going through the solid part.
P waves.
And then there's surface. Yes, and then they're called S waves.
Scientists aren't serious people.
Yes.
Outgassing. P waves.
S waves.
Sulfur dioxide. Yes. So in a larger quake where you can feel the whole thing, what starts off is you hear this, and then wham, boom, and you get this sting like you're on an ocean where it seesaws back and forth, right? So the P waves are the first thing to the right because they go faster. And that's where you get and then when the S wave finally hits, it's going up to the surface and across. That takes longer to get to you. Then you get that big wham. So you experience the conversion from P to S, or the bang thing, and then swaying back and forth. And if you pay really good attention on a bigger quake, you get a feeling like you're on the ocean and things are still swaying back and forth because the ground is still settling down, right? It takes longer, you'll see on the side of it, but yeah, the big bang is that transfer between P and S. That also can give you a notion. And so because the P waves travel faster than S, you can look at a wave thing and say, okay, the earthquake began here, and we saw the P waves coming in and then conversion to S. And so how can you tell? Well, in a typical, this is average rock, it takes about for every second between the rattle and the bang, every second is 8 kilometers or 5 miles. So it's opposite of lightning thunder where you get the differences. So if you had a 2 seconds of rattle, and then bang, it meant the epicenter was 16 kilometers from you in direction, right? Down and up. And so you can kind of tell. So the longer you have that rattle before the bang, it means the quake is probably more intense. You were able to detect it farther away. And now these things we saw in those things you would be hard pressed unless you're sitting down very carefully on the ground to say, oh, it kind of wiggled it, right? But Kilauea, the volcano is a very wiggly spot. You're not going to be falling down. The stuff isn't going to fall off your shelf. Those quakes are much fewer and farther between, especially during an eruption, because as Jess said, things kind of shake out. But great questions.
All right.
What were our predictions from last time? Yeah, let's go.
Alrighty,
Yes.
I bring out the book. So
The book.
Landon had said episode 44 will occur before the next show. It will have one fountain. He was right about that. And approximately around 400 meters. He missed. Nice photographic fountain, which is true. It was a nice photographic fountain with the stream. And then can occur during the show or occur just before the show. So I guess he got everything right on point. Damn. Madam Pele will be proud.
Clap emojis in the chat for Landon.
Yeah.
Good job, Landon.
Thank you. But then Madam Pele is saying, okay, Landon, now you think you're so smart. Let me show you what I'm going to do. So, next time.
Like, yeah, that's what she will say. She will be like, I'm proud of you. That was very impressive. But let's make it a little...
I'm still in charge.
Yeah. Chesh had
Simon.
said, we will not see an eruption fountain this month. Verbal out, continuous gassing, continue to outgassing, dribble flow, free fountain stream of lava flow.
Well, yes, we did see that. The south vent did a lot of dribbling pre-fountain.
Yeah.
That was true.
Yeah.
But it fountained.
I got like 2 points.
Yeah. I said
2 claps for me.
I got
That was more
I
than 2.
said one episode of lava fountain from both events, so I got it wrong. And we'll start with dribbling, similar to episode 43. So I guess I was right about the dribbling, but I got it wrong. All the other stuff was like, everybody got that there's going to be some
1
dribbling.
clap and a half for Maanyaa.
I think she did really well.
All right. So Travis had said, ring of fire in the northern hemisphere will stop and a new one in the southwest Pacific.
I don't think that happened.
Mount Erebus is still erupting, but it has been since
Forever.
for decades.
Yeah.
So
Athens
counted.
had said Athens had said a volcano will go somewhere. Boom.
yes, that's true.
True. That did happen.
And Shano had said the proposed Gold Coast Trump Tower on the the proposed Trump Tower on the Australian Gold Coast be a very powerful 400 feet plus tall in planning, underwhelming, and wider than it is high.
Yeah. Poor Gold Coast. I hope the Gold Coast doesn't suffer that kind of blight, but that's for the Gold Coast.
Yeah.
My prediction for this next month is the same one that I made last month.
Same one as last month. Gotcha. Landon.
I'm convinced
What's
that's the
yours?
way it's going. I just think my timing was off.
Yeah.
So, if we have a fountain, by the way, when is the next show? When is the next show scheduled for?
The next show should be on May 15th, I believe.
On May 15th.
We could do the 8th, or sorry, the 10th, or no, that's not right. The 8th or the 15th, one of the two.
Let's do the 15th.
Okay.
That'll be about a month. And I think in this particular case, if we have a fountain before the May 15th show, it will be, well, we'll have only one. It's possible that will be either it will be erupting during the show or about to erupt. Remember last time we had a case where it's just about to erupt. So I think we may have, again, it may be just about to erupt or it may have just erupted. I think that the fountain, again, will be, medium in height, like we had, like 250 meters. And it may also just be one vent that's erupting, but I'd be more surprised. I'd be more likely to have two vents going rather than just one. So does that give you a clear enough picture?
Yeah, I think so.
Possible,
chat,
but,
make sure that if you want to predict what's going to happen for the volcano next month, get it in now.
Yeah. So Maanyaa, what do you think?
Let me just confirm your prediction first because
Sure.
I don't want to miss it. So you said, so around the next episode, maybe the volcano may be just about to erupt or just erupted. Yeah.
Yes.
Fountain in medium in height, around 250 meters. There might be one vent, likely two, then one.
Yes, more likely two vents in one, and such.
Is there anything else that you said?
Yeah, I think again the height is probably around 250 meters or so.
Yeah, I got that.
Medium in height, like 250 meters ish, as opposed to the big tall one.
Yeah. Okay.
And we'll over the next week, if we see the tilt meter slowly going up, it'll be that will suggest a repeat on there. But I think we'll be heading towards episode 45. Now, beyond that's a different story. So what do you think? What do people in the chat think?
They really don't like Tom.
My prediction. Oh, okay. My prediction is I don't know. I will say that we'll just see it dribble. That's all we'll see from one or two of the vents, not a fountain.
Is that dribbling because it hasn't yet fountained, or you think when it does
just
erupt,
the dribble,
it'll just be,
the episode
won't be in a fountain at all?
Yeah.
Now your prediction might be a challenge because if the it's like a month from now and it's heading towards the thing, but you're saying that when we see the deflation occur, there won't be a big fountain. It'll just be kind of oozing out.
No, oozing out. Yeah, that's what I said.
And at some stage, Maanyaa, I think you're going to be right. At some stage, when this episodic system stops, we won't see the big fountain rush. And we know that there's more material going out than coming in. So at some point it has to stop. The question is when.
Yeah. Yep. Okay. So anyone in the live chat? Do we have anything in the live chat?
Yeah. We have Orange Dot said 5 days before the next stream, there's going to be a 200-meter event in height.
Okay, 5 days before.
That's a good.
That's I could see that. And the argument about what Orange Dot says is that because the drop from this fountain was low, it didn't relieve the pressure as much, and so it's starting from a more pressurized thing, which might mean that it happens a little bit sooner than what I'm thinking. So Orange Dot may have a point.
Yeah.
Victoria says, my prediction is there will be something out, but not a fountain, because the fountains will be over.
Okay. It's kind of that dribbling thing, which at some point when the pressures are not as extreme when it blows, it's just going to be oozing. Much of the time, Kilauea's classic eruption starts with a little bit of fountain and then just flows, right? That's usually the case. This episodic stuff we've been seeing since Christmas Eve 2024 is unusual in historic film.
Okay, we'll remember that. All right.
So what is it? What's it? Someone's prediction?
Yeah, my mom's prediction is that the day after the next stream will be my birthday.
And well, it turns out that my mother, if she was alive, would have her 97th birthday on the stream. So,
whoa!
Oh wow!
Mommy was born 97 years ago on tomorrow, next month's stream. But your prediction, you have a stream. So Josh's mom, do you think that Kilauea will honor your birthday with an eruption?
Oh, interesting.
As Pele is just landscaping, GTFO out of the way. Yes. Yes, that front you saw of the front, besides being thermally intense, that particular lava is actually much thicker. It's already outcast, right? The thing that happens with those fountains is that as the lava spring up high in the air, the gases coming out of it, that's really a tephra, and what comes down is a degassed, thicker thing. They're actually even seeing streams of obsidian and other things that are forming in that area. So that landscaping is actually pretty dense rock that comes into play. The other things, yeah, I have no predictions about the what it goes on the Gold Coast. That's a different thing, but yeah. So Jesh's mom, do you think Pele will honor your birthday with an eruption?
Maybe from one mom to another mom, I guess. Yeah. It's possible.
I think so, and if that is indeed the case, we will be able to tell that it's nearby. We'll see the tilt meter up, up at a peak, and we'll see glow coming from the vents as
she said yes.
Is near the surface. Okay, good. Yeah, I think that's quite a possible thing. I mean, that's another possibility as well. So, any other ones that people have?
Nope, that's it. Although Dead Red Eye did say Pele is landscaping. Get the fuck out of her way.
Yes. Yeah, I got that. So let's put that down as a prediction that she will be landscaping.
Yeah.
Yep.
Do not stand in the way of love that wants to go through you.
Somewhere, yeah.
You have a bad time.
Yeah.
Well, that's it for us. Thank you so much for joining us on this Debate Hub, on our monthly show where we track Madam Pele, the volcano, Kilauea, and we've been doing this for like over a year and a little bit now, and I think we've gotten pretty good at this. I think we got a lot of information. I definitely recommend checking out the playlist and see how bad we were at the beginning, except for Landon, and then how much better we've gotten. And how much we've learned about volcanoes. We only need about 150 some odd watch hours left to get this channel monetized. And please leave us comments on anything that you watch, and make sure to like and share, because this has to be the new debate hotspot, because Lord knows all the other ones have fucking eaten shit, for lack of a better term.
That's right. And thanks, folks, for coming on for this ride. You are seeing, because we've been at it for, has it been there for a couple of years now?
It might be 2 years now. 2 years now.
Yeah, I think like 2 years
the show,
so. And you're beginning to see the rhythms of the volcano. and at some stage we'll go into the volcano will go to rest again, and then we'll get excited as it erupts again. So
Yeah.
thank you very much, because you're seeing the ebb and flows of active geology. So thank you much.
Check
for
the links in the description down below, and I will make sure to get this little art of Landon, since we can't see him on stream all the time. I'll make sure to start getting this on the stream while he's talking, so that way we can see him. So there's a little Landon represented while he's chatting away. Thank you so much.
And the little critter there, the
little Pokemon. It's a cast form.
Yes.
Ooh.
Yeah. So cast form doesn't actually have a volcano form, so we invented one for Landon.
Yeah.
Oh, nice.
I'm really good at drawing fake Pokemon. Yeah, it matches.
And we do have a rum and coke coming up.
Is rum and coke tomorrow night, so make sure you join us for that. And there is going to be a debate/discussion with Dr. Kip Davis, a biblical history scholar, and MC Toon, local beat-up flat earth guy. And they're going to be discussing flat earth in the Bible and how prevalent it is or how relevant it is to either flat earth arguments or whether or not it's useful or not useful, and et cetera, et cetera, et cetera. It's going to be a good time. If you have any questions for them, let me know.
Yeah. And for politics show, debate pub on the
25th.
On the 25th?
Yep, on the 25th, that'll be that. And I believe there's a video coming out here tomorrow that was a debate/discussion with Dapper and Cindy Lincoln that happened a couple of years ago. Ooh. So definitely go and check that one out, because it's still relevant and very interesting.
And then get your predictions in on whether or not how soon Chesh replaces her batteries for her
Not even once. It's not even once. It's on the ceiling. I'm not touching it. I already did the work to get it down, so it wasn't
good idea
during the show. Yeah, it's dangerous for me. I gotta get my grappling hook out. I gotta shoot it into my ceiling. I gotta overhand climb it like I'm Donkey Kong.
Thank you very much for joining us.
Have a good day, everybody.
Thanks, everyone.
Bye.
Cheers.
Bye.
Bye.